In this section, we're going to talk about the quotient rule for finding derivatives. Let's recall what the product rule for derivatives is. I'm taking the derivative of a product, start at the first, take its derivative, multiply by the second function left alone, plus now the derivative of the second function times the first function left alone. The product rule for derivatives. Okay? In this unit, we're going to learn the quotient rule for derivatives so that we can determine the derivative of functions in the form of f over g, like sine x over x squared plus 2, or this or that. Quotient rule for derivatives. Okay, so the quotient rule for derivatives, let's do it in its most general form with an f and a g. So I'm finding the derivative with respect to x of the derivative with respect to x of f of x divided by g of x. Okay? So the first thing you need to know about the quotient rule is that the quotient rule yields a quotient. You're going to get another quotient here. Okay? In the numerator of this quotient, start at the top. You must start at the top and take its derivative, f prime of x. Multiply by the denominator function left alone, minus, not a plus. And then the derivative of the bottom function times the top function left alone. That is the numerator for the quotient rule. In the denominator, no derivatives. No derivatives in the denominator. Take your denominator as it is, whatever function is there, and square it. I call this the denominator left alone but squared. Okay? So look at the numerator of the quotient rule and look at the product rule. They are identical except for the sign. So that's why I say plus for product rule, plus for product rule. Quotient rule gets a minus and it has a denominator. So that is the quotient rule for derivatives. Let's apply it to this function. Here we have a quotient and we're finding the derivative, so I will use the quotient rule, which says I start at first of all, it yields a quotient. Start at the top and take its derivative, 5. Multiply by the bottom left alone. Minus is in the quotient rule. Now the derivative of the bottom times the top left alone. And that is the numerator. And in the denominator, excuse me, in the denominator we take our denominator left alone but squared. And that's it. This would be a safe stop spot. If I needed to for a multiple choice answer, I might have to distribute and combine like terms. Number 2, find the instantaneous rate of change, IROC. That is derivative, instantaneous rate of change. Okay, remember you guys, AROC is change in y over change in x. IROC, instantaneous rate of change, is dy dx. It's the derivative. Okay, so here's our y. We want to find dy dx. In terms of x, that just means we will have x's in our answer and no other variable. Okay, start at the top. First, it's going to be a quotient. Start at the top and take its derivative, 2x. Multiply by the bottom left alone, minus the derivative of the bottom is a negative sine x times the top left alone. All divided by the bottom left alone, but squared. Okay? This will be a safe stop spot, right? As a multiple choice, they might write this as 2x cosine x. They would always write this x squared in front of the trig function. So plus x squared sine x divided by cosine squared x. Does a cosine cancel? Absolutely not. There is no cosine in this term, and there's a plus right here. Absolutely, you cannot cancel that. Number 3, what is the slope of the tangent line to this curve at the point when x is pi over 3? So first we're going to find the derivative. That's the meaning of derivative. And then we will plug in pi over 3. So let's find g prime of x first. It's a quotient. G is a quotient, so g prime will be a quotient. Start at the top, take its derivative. Derivative of secant x tangent x. Multiply by the x left alone. Minus is in the quotient rule. The derivative of the bottom is just 1 multiplied by the top left alone. Okay, all divided by the bottom left alone but squared. You guys, when you are that reminds me, extending my fraction bar reminded me of something. It drives us all, it drives teachers a little insane when students write a little short stubby division line, quotient line, okay? Do not write a little short stubby one. It drives us insane, and it can be misleading into what your answer is, what your work is saying, okay? So no stubby quotient lines. All right. Okay, let's go ahead and plug in pi over 3. All right, I'm going up top. Secant of pi over 3 is 2. Tangent of pi over 3 is square root of 3 times x, and x is pi over 3, minus secant of pi over 3 is 2, divided by pi over 3 squared. That's going to be pi squared divided by 9. This would be a safe stop spot, but let's clean it up so you guys know how to clean this up for a multiple choice answer. I'm going to multiply top and bottom by a 9 to get rid of this 3 and that 9. When I do that, I'm going to get, okay, 3 goes into 9 3 times. 3 times 2 is 6, so I'm going to have 6 pi square root of 3 minus 18 divided by pi squared. And that's it. It is common to write the pi before a square root, and here's why. If you write that pi after the square root, if you said square root of 3 pi like that, students sometimes don't clearly say if the pi is under the root or outside of the root. Here it doesn't, it's like halfway, it's ambiguous. Anything ambiguous is wrong, okay? So you can leave the pi afterwards, but you need to very clearly communicate that the pi is not in the square root, okay? All right. Alrighty, one more here. Okay, find h prime of 2 if this is h. Alright, well, first thing I see is a quotient, so I'm going to apply the quotient rule, which yields a quotient. I start up on top and I take the derivative, and the derivative of 7 is 0. So this first term is going to be a 0. I could write that I'm multiplying by the bottom, but I don't have to because it's just 0. Minus the derivative of the bottom is 3x squared times the top left alone, all divided by the bottom left alone but squared. And now we're going to find h prime of 2. Okay, Notice, you guys, I'm writing this in two separate steps. Do not put an equal to sign and start plugging in 2, because you are saying then that two things are equal which are not equal. So don't do that. Okay, I have 0 from this piece. This is going to be a negative 21 times 2 squared divided by 8 plus 8 squared. That is 16 squared. You know what I'm going to do, just because I don't want to multiply a whole lot? I'm going to take, this is 4 squared times 4 squared, right? I'm going to take one of those 4's and reduce it. And so then I don't have a 4 up here, and instead I have 4 times 16, which is 64. Alrighty? So negative 21 over 64. Let's do a little check on that one. Derivative of 7 over parentheses x cubed plus 8. Make sure you put parentheses around the denominator, otherwise you are only dividing by the x cubed and then adding 8 to everything. At 2. And then let's do negative 21 over 64. And yep, it is correct to 3 decimal places. At least 3. All right, higher order derivatives, you guys. Higher order derivatives. dy dx is the first derivative. This is Leibniz's notation. And this is Lagrange notation. Okay, oops, that's off the screen. Leibniz and Lagrange. The primes come from Lagrange, all the d's come from Leibniz. This is the second derivative. Okay, this is Leibniz's notation for the second derivative. This is Lagrange's notation for the second derivative. Third derivative. So Lagrange just kept adding primes until you get to 3. After 3, he used this notation, and you need to recognize that. When there are parentheses up here, it has nothing to do with a power. It has to do with derivative. Okay, we never use parentheses up here for anything else except derivative. Okay, we could, if we wanted to, we could write this as that. And f double prime, we could, if we wanted to, write it like this. For f prime, we could write it as that. Okay? We don't. We usually write the little primes, but anything higher than 3, you don't keep on writing primes. That would be ridiculous. Okay, so let's do number 5 here. Let's determine g double prime, given that this is g of x. All right, well, first we're going to find g prime, and then we will take the derivative of it. So I look at g, and it's a product, so I'm going to use the product rule. The derivative of the first thing is 1 times the sign left alone, plus for product rule. Now I'm leaving the x alone and multiplying by sine x. The derivative of sine x is cosine x. So g prime is equal to sine x plus x cosine x. Now we're going to take the derivative again. It's a sum, so we take the derivative of each piece. The derivative of sine x is cosine x plus, now here comes another product rule. The derivative of x is 1 times the cosine x left alone plus, now we're leaving x alone and multiplying by the derivative of cosine x, which is negative sine x. This would be a safe stop spot, but I think I might want to clean that up and make it that. Okay, let's find the fourth derivative of this polynomial. So first I will find the first derivative using the power rule. There's no products in here. Okay, so we'll have 6x to the 5th plus 10x to the fourth minus 8x cubed plus 9x squared minus 20x. Now we're going to find the second derivative. Since they gave me Lagrange notation, I'm going to use Lagrange notation, but you could totally just, well, I wouldn't say f, there's no f, maybe y prime. You could use y prime if you prefer, okay? But I want you to get used to using all of the notations. All right, taking the derivative of each piece now, we have 30x to the fourth plus 40x cubed minus 24x squared plus 18x minus 20. Time for a third derivative. 120x cubed plus 120x squared minus 48x plus 18. Another derivative. Oops. Fourth derivative. Okay. 3 times 120, so 360x squared plus 2 times 120 is 240x minus 48. So there is the fourth derivative. We could keep on going, because why not? The fifth derivative would be 720x plus 240. The sixth derivative would be 720. What would the seventh derivative be? 0. We started with a sixth degree polynomial. And look at what happened as we went down. Okay, each derivative decreased the power by 1. So by the time we got to the sixth derivative, the power was 0, and the seventh derivative, the derivative was 0. Okay, let's do this one, and then we'll call it a day. Let's find h double prime at 1. So h prime of x will be, the derivative of 3 is 0. This is going to be a 4 minus 15x squared. The second derivative is negative 30x. So the second derivative at 1 is negative 30. And that is it for the quotient rule.